Allocation. In this module, you will learn about data structures, sequential memory allocation, basic list operations, traversal in a list, insertion in a sorted list, deletion of an element from a list, searching techniques in a list, linear search, binary search, sorting a list, selection sort, bubble sort, insertion sort. Let us begin the session by understanding what is a data structure. A data structure is a group of data which can be processed as a single unit. You can have similar or dissimilar data types in this group of data. Data structures are very useful while programming, since data structures make managing of data simpler. They allow processing of the entire group of data as a single unit. The very simple example of data structure is an array that stores group of data having same data type. There are two types of data structures, namely linear and non-linear. In a linear data structure, the elements are stored in a sequential order, whereas in a non-linear data structure, sequential order is not followed. Non-linear data structure is like multi-level data structure. Examples of linear data structure are arrays, lists, stacks, queues, linked lists, etc. Examples of non-linear data structures are tree, graph, etc. Among these, list is simplest and most important data structures in Python. List is a sequence of values of any data type. These ordered set of values are called elements or members of a list and are enclosed in square brackets. You use index to identify a value of a list. In this session, you will learn how to traverse, edit, and sort the list. As you know, an array is a set of contiguous data of similar data type. In older programming languages, you need to declare the length of the array at the time of declaration, and it is fixed. You cannot change later in the program. However, now latest languages support variable length arrays. You can change the length of the arrays later in your program. You can consider Python lists as arrays of variable length. The elements of a list are of heterogeneous types, that is, they have different data types. Therefore, 5, hello, 9.5, t is a valid list. This is because in Python language, pointers and not objects are stored in the form of an array. Therefore, a list in Python is an array that contains elements that are pointers to objects of a specific size only. To implement a list, a contiguous array of references to other objects is used. Python keeps a pointer to this array, and length of the array is stored in a list head structure. This way, list index is independent of the size of the list. When you append or insert an item, the array of references is resized. As you know, a list is allocated memory in sequential manner. This means that list elements are stored in memory in sequence as per their declaration. Therefore, if you want to view the fifth element of the list, you must first traverse through first 4 elements of the list. This is known as sequential allocation of memory. Memory is allocated to the list as per its members and their types. Also, if two or more members of the list share the memory, then memory consumption will be quite different from the situation where no sharing is involved. In Python, the length of the lists is not fixed, since you can dynamically add or delete the elements from the lists. Moreover, memory consumption of the list is referenced by a pointer. It takes 4 bytes in 32-bit mode and 8 bytes in 64-bit mode, where mode is referred to the word size of the processor. Therefore, the size of list will vary in bit modes. It will be 4 times the number of objects in the list in the 32-bit mode, whereas size of the list will be 8 times the number of objects in the list in 64-bit mode. Apart from these, every list has a fixed header overhead. There are some other over-allocations involved for all Python lists. Now let us look at basic list operations. The 3 basic operations of any list in Python are traversal, insertion, and deletion. Let us learn each of these operations in greater detail. Traversal in a list is nothing but to move in a list in sequential manner, starting from first element to the last element. Here is the algorithm for traversal in the list. Program code for the traversal in a list will look like this. Please note that here U is the maximum index or upper bound of the list. It is equal to size minus 1. List_test contains only integer elements. We will use these assumptions throughout this session. In this code, the for loop will run until all elements of the list are displayed. If you wish to insert an element in an unsorted list, then you can insert the new element at the end of the list using append method. But if you have the list which is sorted, then the new element needs to be inserted at an appropriate position so that it is placed in order with the other elements of the list. To do so, the rest of the elements needs to be shifted as illustrated in the figure. Let us first write algorithm for this. If you have the sorted list in ascending order, then the appropriate position for the new element, say new LM, has to be identified first. Say if the appropriate position is j plus 1, then list_test j less than equal to new LM less than equal to list_test j plus 1. Here is the algorithm for insertion of new element in the sorted list. You can implement this algorithm in Python to write a program for inserting a new element in the sorted list. However, more efficient and simple way to add a new element into the sorted list will be through the bisect module. It implements the given algorithm in Python to insert elements into the list in sorted order. Have a look at a program that generates a random number and inserts them into a sorted list. This program uses 2 modules, namely random module and bisect module. The random module has seed method, which uses a constant seed. This ensures that the same pseudo-random numbers are used each time the for loop is run. Here, the radent method is used to generate a random number between 1 and 100. The bisect method provides the proper location of the new element. The insert method used in the program inserts the new element in the appropriate position. This program will produce following output. Here, the first column displays the new random number. The second column displays the position where the number is inserted in the list, whereas the last column displays the content of the list. Now let us learn how to delete an element from the sorted array. To delete the element from the sorted list, you need to first search the element that needs to be deleted for in the array using either linear search or binary search algorithm. If the element is found, the element is removed from the list and the rest of the elements of the list are shifted in the way that the order of the array is not disturbed. As the elements of the list are shifted upwards, you will have free space at the end of the array. Here is an algorithm to delete an element from the list. Have a look at the Python code to delete an element at the position POS from a sorted list. Though there are many searching algorithms, in session we will learn about two important searches, linear search and binary search. Let us start with linear search. In linear search, you compare the search element with each element of the list, starting from the first element of the list. It continues till either you find the element or you reach the last element of the list. Therefore, the name linear search. Here is an algorithm that searches for an element in the list named list_test containing size number of elements. Now have a look at Python program that searches an item element from the list called list_test. Though linear searching technique is simple to use, you can see few drawbacks in it. For example, if the searching element to be is at the end of the list, the searching process will consume lot of time. This is because the element has to be searched in a sequential manner, starting from the first element in the list. You can overcome this drawback to a large extent using binary search sorting technique. Let us understand binary search technique in detail. In binary search technique, there are less number of comparisons and hence it saves the processing time. However, for binary search to work, you should have the array in sorted order in either ascending or descending order. Consider you need to search for an element, LM, in a list which is sorted in ascending order. In this case, the element, LM, is first compared with the middle element. There could be two possibilities. One, LM is greater than the middle element, or LM is smaller than the middle element. If LM is greater than the middle element, LM is searched in the latter part of the list. Therefore, the latter part of the list becomes the new sub-array of the array. On the other hand, if you have an element, LM, which is smaller than the middle element, then former part of the list is searched. Here, former part of the list becomes the new sub-array. At first search, the sub-array contains the entire array. In the next stage, the sub-array becomes half of the list. Then, in the later stage, it becomes 1/4 of the entire list, and so on. Here is an algorithm to search an element using binary search. Please note, the variables low and high are the upper bound and lower bound of list_test respectively. Here is the Python program that uses same algorithm to search an element by binary search. Next, let us focus our learning at sorting a list. What is sorting? Sorting is to arrange the list in an ascending or descending order. There are 3 types of sorting techniques which are used to sort the list, namely Selection Sort, Bubble Sort, and Insertion Sort. Let us look at each of these in greater detail. First, let us understand about Selection Sort. In Selection Sort, you select smallest element repeatedly in the unsorted part of the array and then swap that element with the first element of the unsorted part of the list. Let us understand this logic with the help of an example. Let the numbers be 12, 7, 3, 27, and 15 in the unsorted list. Let us sort this. Step 1. Select the smallest element of the list. In this case, it is 3. Now, this element 3 is swapped with the first element of the array, that is 12. So now the list becomes 3, 12, 7, 27, 15. Step 2. Next, again the smallest element is picked up from the unsorted part of the list. In this case, it is 7, which is swapped with 12. Now the list becomes 3, 7, 12, 27, 15. Step 3. The next shortest element from the unsorted part is 12. Since 12 is already at the right position, therefore the list is not changed. 3, 7, 12, 27, 15. Step 4. Next, 15 is swapped with 27. Finally, the list is sorted in ascending order and now it shows 3, 7, 12, 15, 27. The code for a selection sort requires 2 nested loops. The outside loop tracks the current position to swap the smallest value. The inside loop scans the list for the smallest value starting from the current location. When it finds the smallest value, elements are swapped. Here is the algorithm and program code for selection sort. In the bubble sort algorithm, you start comparing from the beginning of the list. Every adjacent pair is compared and swapped if they are not in the appropriate order. Hence, the largest element is pushed at the end of the list. After every iteration of the loop, the last element is compared. This is done till there are no more elements left for comparison. Consider following list that is required to be sorted in ascending order. List elements are 30, 2, 17, 8, 40. Step 1. Compare the first 2 elements, that is 30 and 2. Since they are not in order, these elements are swapped with each other. The list now becomes 2, 30, 17, 8, 40. Step 2. Now compare second and third element, that is 30 and 17. Again, these are swapped since they are not in order. The list now becomes 2, 17, 30, 8, 40. Step 3. Compare 30 and 8. These are again swapped. Now the list becomes 2, 17, 8, 30, 40. Step 4. Compare the last pair, that is 30, and 40. Since they are in order, there is no change in the list. 2, 17, 8, 30, 40. Now the largest element is settled at its appropriate place, that is, at the end. So the first 4 elements form the unsorted part, while the last element forms the sorted part. These steps are repeated again to get the following list. Unsorted 2, 17, 8, 30. Sorted 40. The steps are repeated again till all the elements are sorted in ascending order and the final sorted array is 2, 8, 17, 30, 40. Algorithm for bubble sort is as follows. Here is a bubble sort program written in Python. Now let us look at the third type sorting, insertion sort. The insertion sort selects the next element to the right of what was already sorted. Then it slides up each larger element until it gets to the correct location to insert into the sorted part of the array. Consider the following unsorted array: 17, 13, 12, 11, 29, 14. Step 1. First element, that is 17, is compared with second element, that is 13, and swapped. 13, 17, 12, 11, 29, 14. Step 2. Third element, 12, compared with 17 and swapped. Further, 12 is also compared with first element and swapped since 12 is less than 13. Now the list becomes 12, 13, 17, 11, 29, 14. Step 3. Next element, 11, is swapped with 17, then 13, then 12, then 11 is inserted in the appropriate position. 11, 12, 13, 17, 29, 14. Step 4. Next element, 29, is not swapped since it is in order. Step 5. 14 is inserted at proper position after being swapped by 29 and then by 17. 11, 12, 13, 14, 17, 29. As you observe in the example, the insertion sort can also split the list into 2 sections, the sorted half and the unsorted half. In each cycle of the outside loop, the algorithm will grab the next unsorted element and insert it into the sorted part of the list. The algorithm and program for insertion sort is shown on the screen. In the code, the variable I is used as the boundary between the sorted and unsorted portions of the list. The algorithm scans to the left of the variable I using the variable pointer. Note that in the insertion sort, pointer goes down to the left rather than up to the right. Each cell location that is larger than key value, temp gets moved up to the right 1 location. When the loop finds a location smaller than temp, it stops and puts temp to the left of it. In this module, you have learnt a data structure is a group of data which can be processed as a single unit. There are 2 types of data structures, namely linear and nonlinear. In a linear data structure, the elements are stored in a sequential order, whereas in a non-linear data structure, sequential order is not followed. List elements are stored in memory in sequence as per their declaration. The three basic operations of any list in Python are traversal, insertion, and deletion. Traversal in a list is to move in a list in sequential manner, starting from first element to the last element. To insert an element in an unsorted list, insert the new element at the end of the list using append. Whereas for sorted list, the new element needs to be inserted at an appropriate position so that it is placed in order with the other elements of the list. To delete the element from the sorted list, you need to first search the element that needs to be deleted for in the array using either linear search or binary search algorithm. There are two types of searching algorithms, namely linear search and binary search. In linear search, you compare the search element with each element of the list, starting from the first element of the list. It continues till either you find the element or you reach the last element of the list. In binary search technique, there are less number of comparisons and hence it saves the processing time. However, for binary search to work, you should have the array in sorted order in either ascending or descending order. Sorting is to arrange the list in an ascending or descending order. There are three types of sorting techniques which are used to sort the list, namely selection sort, bubble sort, and insertion sort. In selection sort, repeatedly smallest element in the unsorted part of the array is selected and then swapped with the first element of the unsorted part of the list. In the bubble sort algorithm, you start comparing from the beginning of the list. Every adjacent pair is compared and swapped if they are not in the appropriate order. The insertion sort selects the next element to the right of what was already sorted. Then it slides up each larger element until it gets to the correct location to insert into the sorted part of the array.